For number 21, our equation is r to the third power over square root of r squared plus a. A is just a constant. You can look at a as like 9, okay? And we're going to take the derivative of this equation with respect to r. So let's begin. ds over dr. Use the quotient rule, which it says let's square the denominator first. So I will take square root of r squared plus a, put that in the parentheses, and I'll square that. And for the numerator, I'm going to take the the bottom function and put it on the top. So here I will get square root of r squared plus a, and I'm going to multiply by the derivative of r to the third power. The derivative of r to the third power is 3r squared. Subtract the top function, which is r to the third power, and times the derivative of the bottom. And by now you should be comfortable with just looking at this and then kind of write down the derivative of square root of r squared plus a. So I'm going to multiply. The derivative of square root is just 1 over 2 square root of whatever we have inside. So that's the square root, right? That's for the square root. So I have this. And then don't forget we multiply by the derivative of the inside. R squared plus a, the derivative of r squared is 2r. The derivative of a is 0 because that's a constant. So I have to multiply by 2r like this right here. Now we just have to do some cleanup. And as we can see, first of all, perhaps we can cancel these two 2's together. And let's put things slightly nicely for now. So I'm going to write down, here I will get 3r squared and the square root of r squared plus a, right? And I'm going to minus, let me leave some space. I'm going to minus r to the third power times r, that will give us r to the fourth power, over square root of r squared plus a, everything on the top, over the denominator square, which I will just end up with r squared plus a like that. Now, the reason I left the space right here in between is because, as you can see, we have one little fraction here, and we have a big fraction here. So this is a complex fraction, and the way that we're going to take care of this is we're going to multiply everything by the denominator of the small fraction. So let me multiply everything by square root of r squared plus a, and let me do that right here as well. Square root of r squared plus a, and on the bottom, let's put this in the parentheses and multiply that by square root of r squared plus a. Okay. All right. So if after I do that, what am I going to get? 3r squared. Okay, 3r squared. The square root times square root. By the way, this is 3r squared, just like that. Square root of r squared plus a. Two of them becomes just regular r squared plus a. And then for the next part, the square root r squared plus a cancel with this one, right? So I just have minus r to the fourth power. So minus r to the fourth power. All over, and on the denominator here, let me just kind of play around with the exponents. Because notice that the insides are pretty much the same, r squared plus a. But this right here, let me write this as r squared plus a to the first power, right? And this right here, it's like saying r squared plus a to the 1/2 power. All right, so now let's take care of business on the top. 3r squared times r squared plus a. I can distribute this inside. Okay, I can distribute this inside. 3r squared times r squared, that gives us 3r to the fourth power. And I will multiply 3r squared times a. So I have 3, let's put the a first, 3ar squared like that. All right, so I distribute that. Now finally, I'm going to put down the results together. Equals to right here. So after I distribute it, I will get 3r to the 4. And then minus r to the 4. That will give us 2r to the 4. And we maintain the plus 3ar to the square, 3ar to the second power. It's 3ar to the second power. And on the bottom, well, they are the same, so we can just add the exponents together. 1 plus 1/2 is 3/2, and that will turn into square root. And notice that we say 3/2, so that's why the denominator becomes the square root, and the 3 is still the exponent, and we can write this as the inside is r squared plus a to the third power. So as you can see, our answer is choice C. Got it.